So, when these forces occur, they occur along these things called faults. Something called a fault plane. And basically what the fault plane is the natural break within the rock. And this is where you get these different blocks of land that are moving relative to one another. So that's really all a fault is the plane on which the blocks move compared to one another. And we had three different types of faults. And each fault is dependent on the type of force that's applied. So you get different faults for different forces. So we're going to relate these back to one another. So first is called a reverse fault. What type of force is applied in a reverse fault? Looking forward, what does it look like? Yeah, so what's that called? When we have them, look at the blue arrows, those are your forces. So what type of force is that? Compression. It might have also helped if you guys just simply look at this diagram right here. This has compression. Alright, so we'll put this into motion here. So in the reverse, we have two things. We have the footwall and the hanging wall. Now, the line that they're moving on, that's called a fault plane. You see this line right here. Now, the easiest way to identify a reverse fault is notice that this cliff is hanging over the footwall. You guys see how that kind of juts out and is actually hanging over it? That's what they call the hanging wall. It's actually the very top that's going to hang over the footwall. Now, that open face right there, if you can imagine this being on the other side, looking at that, so what you're kind of looking at then is this shape like this. You have this hanging wall right here. This piece is called a fault scarp. So reverse is a compression force, and it creates a hanging wall. Again, we call it hanging, then that cliff face is going to be hanging over the other wall. Now, all right, take these two blocks of land. What do I have running through the top? A river. Okay. Now, as I compress these two together, this one gets pushed up. What do we call this land right here? No. Fault scarp. All right, so this block of land right here we call the fault scarp. But if this is my river, what did it just create? A waterfall. So a lot of the waterfalls, not all waterfalls, but a lot of the waterfalls that we have around the world are indications of reverse faults in our old fault lines. One of the most important fault lines that you guys might be aware of is where? Niagara Falls. Okay? I remember watching some videos on Niagara Falls. They always call it the Niagara Escarpment. Okay? The scarp, remember the scarp face right here. So escarpment is kind of the same thing. It's that raised piece of land due to that old fault line. And so that's kind of important to make sure you guys get that down and you guys understand basically that's how those things got there. So that's when we talk about reverse fault. The next type of fault is called a normal fault. And it's very similar, except for what type of stress is involved with normal. Tension. In our tension, we're no longer being forced into one another. What's happening? We're being pulled apart. So now my hanging wall's aiming down. Now again, the difference here, when you look at the difference between the reverse fault and the normal fault, reverse fault has that hanging cliff face, and a normal fault, we still get a waterfall, right? We still going to get a waterfall right here, but it's angled back. Okay, that's probably the easiest way to tell the difference between a normal fault and a reverse fault. The normal fault, that escarpment is angled back away from the fault, whereas with the reverse, it's angled forward. You guys see the difference there? Okay, so this is reverse, this is normal. And then the last type of fault that I want to talk about is something called a strike slip. In a strike slip, we have basically a shear force being applied. And all that's going to happen is the two blocks of land are literally sliding past one another. Now, this should ring some bells, right? Where have we seen these types of movements before? Think about it.
Plate tectonic.
Coming together, moving apart, sliding past one another. It's just like the plate boundaries. Okay? So when you think about these forces in the fault, the faults are like miniature plate tectonics taking place. It's happening on a local level, not so much on a grand scale. Now, what's really interesting with the strike slip faults, and you can see this with the San Andreas fault in a couple of places in California. Well done. What's happening is we have our river, right? But in a strike slip, they're moving away from one another. What did that just do to the river channel? Split. Okay? Doesn't necessarily kill it. What happens is the water hits that fault line and flows down the fault line back to its original channel and then continues on. So it actually has like this 90-degree turn and then it continues on. And so you can actually see that in a couple places on the San Andreas fault. Also, one of the first things that they did after the 1906 earthquake of San Francisco was they actually sent a couple of geologists out to actually figure out what's going on. And there are pictures of a fence row that got shoved back 8 feet. So that's how much those two blocks of land moved in one single earthquake. So you used to have a fence row, think about the river right here, your fence row, and then literally just split and moved. It's either 6 or 8 feet. A considerable distance. When you think about being a single earthquake, that's a long way to go. When you think about the fact that most of our plates only move 1 or 2 centimeters a year. 6 to 8 feet all at once is a big distance. So, all I'm showing you guys here are some basic, simple blocks of land moving around, right? So you guys want to know what they actually look like in real rocks. Okay. I know, most of you guys don't. So this example right here is called the reverse fault. How can you tell it's a reverse fault? You guys see the layers of land right here? Okay, where's my fault plane? You guys see it? This is going right up to here. And you actually can see the line of the actual fault. And like I said, these aren't necessarily huge. Oftentimes we see these in road cuts. So we look at our fault line. Basically this line right here. And again, notice that this piece right here is being shoved up, and you actually kind of see that open face or angled over it. So that's going to be the reverse fault. Here's an example of what a normal fault. When we talk about the scale, this gives you guys a perfect idea what the scale actually looks like. So this is your normal fault. Again, you can see that crack going right down the center there. That's your fault line, your fault plane. And then this picture is right out of your textbook. This is your strike slip. You can see how the rows of the orange trees are offset, and that right through here, that line is again the fault plane. And here's another example being shifted over just a few inches. So again, we have a strike slip there. All right. Well, that's all I have for us.